Okay, so this is the Algebra 3 class, hopefully. Third hour. Yay.
Yay.
Okay, yes. What's up?
Do you have another copy?
Another copy? They're up here. Yeah. Okay, so now, long break. You guys, remind you a couple things. Please make sure your headphones, phones, all that stays away. I will kindly remind you, so please try to pay attention, focus, participate in this. I'm going to do my best to get you all passing. All right, so right here it says 4 cylinders, so the least material. So of this one right here, which cylinder needs the least material to build? So if we think about it, which one of these do you think is going to use the least amount of material? D? Why D? Because what? It's the smallest, but it's wider than the others. The other one's taller. B? B, C, D. So all of these, because there's none of them actually gives you any value, if you were to justify what information would be useful to determine which one it would take. What information do you think would be helpful for this? How about the radius? These are all cylinders, right? The cylinder, so I would need the radius. Come on. So we could use the radius. What else could I need? Some height. So all those things would be helpful, but other than that, we're just taking guesses at it about how big these actually are. So this one right here, whichever you decided on yours would work, as long as you're able to still justify it and talk about it why. Figuring out the dimensions. So there are many cylinders with volume of 452 centimeters cubed. Okay, so the volume of a cylinder. So find the volume of a cylinder that you need the formula. So the volume is equal to, it is pi. I wrote it 2, but I don't know why. So it's pi r squared h. So for the volume of these cylinders, it's pi r squared h. So you're going to need this formula over and over again. So I'm hoping you write it down, because it's necessary to find this. So complete the table. So first, let's go through and figure it out. So I know what the volume is. I know what the radius is. I just don't know what the height is going to be. So what I'm going to do is I'm going to take this, I'm going to do some algebra to make this into h equals. Because that's the variable I'm looking for, right? Hopefully, yes? Okay, all these things right here being multiplied by h, right? How do I undo the multiplication? Divide. So I'm going to divide both sides by, not h, because I'm trying to get h by itself. Pi and r squared, right? Both of these. I'm going to get rid of both of them. So it's going to look like this. Pi r squared. Pi r squared. So on the right-hand side, those cancel. So I should have h is equal to v divided by pi r squared. So now we have to go through and start picking some of these things out. So for my first problem, my radius is what? 1, right? It's right here. Radius is 1. So the radius is 1 right here. So that would be my volume, my V, which is 452, right? So 452 divided by pi times, I'm going to put it in parentheses, 1 squared, like that. So you guys are going to start doing this in your calculator right now, and you're going to fill these in for us. So I've set up the formula. I set this up. So now you guys are actually plugging these in. So as I plug it into the calculator, I'm going to bring up my calculator so you can see this. So 452. So hit Control Divide. 452 over pi times parentheses 1 close square. So if you set this up, then every time you do this, you could actually just use the calculator. So watch this. So enter. So my height is going to be 143.8. And then to do it again, watch this. I'm going to arrow up twice, hit enter, and then I just change my 1 to a 2. And that's my next problem. So 143.9. And you guys are actually going to do those right now. So go ahead, go through and fill those in. I'll turn the lights on so you guys can see. Times. Okay, so we have the next one, so it's going to be 2 squared. 2 squared. Enter. There we go. Okay, you just keep going through like that. So you don't have to redo it every time, you just arrow up twice. Enter, and then not change your mind. I think I would watch. Go up, hit enter, and now you can adjust it. Okay, if it's already over here, then you can't adjust it. Okay. Sterling, okay. Good. 452. So now you forgot to divide by. So now I'm going to control divide. Now on the bottom, that's where you push your pi. Times. Okay, 1 squared, 2 squared, 2 squared. Okay. Yes. So now you can modify it. So down here it's times 2 squared. Okay. Okay. R. Just any value of R. It's going to be whatever value. We did that up here. Right? Yeah, no. Put the whole, yeah, that's what we did first. All right, so let's go through and see what we got. Okay, so at 2, what was my height?
35.
35.9. Okay, what was 3?
15.9.
15.9. What is 4? 8.9. What is 5?
5.7.
5 point what? 7. 6?
3.9.
7.
2.9.
8. 2.2. 9.
1.7.
10.
1.4.
1.4. And R, that's this one right here. So it's going to be 452 over pi r squared. So we did that first. Okay, so now on the next one it says, here's a graph with the plotted pairs from the table of the coordinates plane. What do you notice about the graph? Now let's look. So my answers are actually already here. So at 1 it was 143. The next one's going to go down here, and it was 35, right? There we go. And then you keep going. What do we notice about the graph? It's decreasing, right? Decreasing a lot. Will it ever go to 0? It can't go to 0. If it went to 0, what did that tell me? Anything times 0 is 0, right? Anything times 0 is 0. So I wouldn't have the same volume. So even though I'm multiplying for the volume, I wouldn't have a volume. So it can never be 0. So we know that this is something like that. So this is actually like an exponential. Okay, so let's take a look at the next one then. Okay, so right here, same thing. Many cylinders with a volume 452 centimeters cubed. Let R represent the radius. H and S represent the surface area. Now, we're doing surface area now this time. So we need the formula for surface area, so that one's actually going to be interesting. So surface area is supposed to be just the side length. Just the side length. I hope it's just the side length. So anyway, it's going to be, so if I look at it like this, so it's basically a can. We took the can, we cut it down the side, and we laid out the top and bottom. So to figure that out, I know that this value right here, from here to here, is going to be my height. And I know that this piece right here wraps around my can. So if this piece right here wraps around this can, that'd be the same as saying the circumference. That'd be the circumference. So this value right here would be the circumference. And the circumference of a circle is going to be 2 pi r. So I gotta double check my notes before I actually do this next part, because I don't want to mess this up. Okay, because I'm not sure if they're asking for the top and bottom in the surface area. It doesn't say, so I wanted to make sure I'm double checking my notes on this. Okay, so yes, they have the top and bottom also. So now, the area of this right here, the area of the top, the area of a circle is going to be pi r squared. And how many of those circles do I have? I have 2 of those. So I'm going to put all this together into one formula. So I know I have a top and bottom, since I have 2 of those. So my surface area would be 2, and it's my pi r squared. So that's going to be my top and bottom. And right here, plus, I need to find the area of this piece right here. I need to find the area of this. So, isn't this like a rectangle? Yeah, it is a rectangle, right? So it would be the base times the height. But since I'm only dealing with formulas right now, I don't know what the r value is. I don't know what the h value is. I'm eventually going to find those, but it's going to be this times the h, right? So I'm adding 2 pi r. Okay, that's my base times the height, which is my h. So I just made the surface area formula. Okay, so now we're going to actually try to do some of the math to go along with this. Okay, so for this, we're going to go through, we have the r and we have the h, and we're going to find the surface area. So what you people are going to do, s equals 2 pi, my radius, for this first one is 3, squared, plus 2 pi 3 times my h, which is, in this case, 16. So I plug that into my calculator. Two pi times 3 squared, so I don't mess this up, plus, yeah, 2 pi times 3 times 16. 3 and 16, right? Yes. Alright, hit enter. And my first volume is going to be 358.1. Or my first surface area. 358.1. So you people right now, you guys are going to calculate the other ones with the different radius and the different height. Lights. So this is just a whole lot of calculating.
So it's 2i times, so this times my r, which is 4 times 9, your h. Enter. Mm-hmm. Oh, it's right. Oh, can you see it from there? The bottom. Yeah, this is what we're plugging in. So now we're changing the radius, right? So we're changing this. Or this is now going to be 4. So the r's are 4 and the h is 9. Okay? So change those up. You have 2 and 2s. Good.
Yeah, okay.
All right, let's see where we're at now. All right, so the second one. So the 4 and 9 gives me what? 326? 0.7? Okay. 5 and 5.8? 339? Point what? 2. 3.5? 2. 3.75?
328.
Point.
6.
Okay. 4.25?
327.1.
4.5.
I don't have it.
You don't have it? Anyone have the 4.5? 327? Okay. There you go. Thank you. All right, so now let's look what we got here. So looking through this, what do we notice? So getting the most out of this so far is going to be this one right here, the radius of 3 and the height of 16, isn't it? So that's going to be my highest point right there, right? So that would be giving the same amount. Okay, that would be giving more surface area than the rest. So now whenever we're making something like this, so let's say for instance you're in some type of trade. You have to build something. So you decide, hey, I'm going to make cookies for a living. So I'm going to put cookies in a box. Okay, or a cylinder. Yeah, even better. So cylinder, that works. And so you have to calculate how much this container is going to cost you for putting your cookies in. So stuff like that. This is where this actually comes into play for real life. You're trying to maximize the amount. So you want this to cost the least amount for you and get the most out of it. So we want to be able to put the most cookies in it, and it's going to cost the least. So that's kind of what we're looking for here. And it happens right about in the 4-ish area, right about here. That's the lowest point. So that means it's going to be the least amount of surface area. right, so let's see. Write an equation for S, function of R, when the volume of the cylinder is this. Okay, so function of R. So now that I'm going to turn this right here, this one right here, into R equals. Actually, no. It is that. So write an equation for S as a function of R when volume is 452. So now I would set this volume being 452. So that is from my previous problem. That actually came from over here. So we're dealing with volume on this because you want to put as many cookies as you can in your container, and then I want my container to be small as possible. I don't want to pay a lot for my container. So I'm going to set that up. So I'm going to write it in regards to my R. So let's see, I have insert page after. So I know on this one, I had this information. So I have 452 pi r over r squared, right? There's my h value. Then from this one right here, I also have s equals, and I have an h value over there. So it's going to be my s equals 2 pi r squared plus 2 pi r h. Now, this is going to be one of the things that's slightly confusing. So, how many variables do I have in that second line right there? There's 3. I can still count s as a variable. It could be 2 or 3 depending on which I'm looking for. So now, given this, I'm going to go through and actually try and make this into a function that goes along just in terms of r. Because I use my volume, which I got from here, and I don't want h. Oh, wait, too far that way. I don't want h. So what can I replace h with? This one right here. I can replace s with all of this right here. Not s, I'm sorry, h. I can replace h with all of that. So that's what I'm going to do. I'm going to replace h with all of that. It says right here, write an equation for s as a function of r when the volume of the cylinder is this. So I took that from there. So now it's going to be s equals 2 pi r squared plus 2 pi r. Now h is going to be replaced with 452. Now, if I look carefully, do I have a pi up here on top and a pi on bottom? What can I do with that? I can cancel out, so I'm going to. What about, I have an r right here and I have an r squared on bottom. I can cancel out one of them. So I'm going to cancel out this pi's, this r, and I'm going to cancel out the r squared. So now it's going to be s equals 2 pi r squared plus 2 times 452 over r. So now I have a function for s in terms of r. So that means that only variable I have now is r. So I can go through and actually figure out what values of r would actually make this work. Okay, where am I at? There we go. So right here. Okay, so we have an equation for that. So now if I wanted to go through and try and find values of R, that's going to give me a volume that I wanted because my volume was my 452. My volume is 452. That's where I get that. And then my surface area is going to change depending on whatever my radius is going to be. So I can change those as necessary, depending on how big the cookies are that you decide on making. Is everyone just trying not to fall asleep right now? Am I making any sense or no? Kinda? Sorta? I'm going to tell you right now, all these exercises is a lot of just calculator work. Okay, plug it into the calculator. You got a lot of work. Fill in all your stuff. Okay, this is a kind of difficult concept because you're dealing with volume and area at the same time. But other than that, all right, I'll let you guys start on those because you need the calculator to do the practice. All right, like, share, and subscribe. Right? Hit that notification button. Leave comments. No, don't leave comments.